Hi there, welcome to this build of a Clancy Aviation 40-inch wingspan Speedy Bee. Now you can see from what I've got laid out in front of me that we've got to a pretty advanced stage with this build now, and essentially I think we've got nearly all of the balsa construction done. There's a little bit of stuff to do, like the hatch, the cover on the nacelle, a little bit of balsa here, a seat here for the pilot, but essentially we've got the bulk of it done. And the next stage now is quite critical. What we need to do is start fitting out the control servos for the elevator and the rudder for the throttle, and we need to decide where we're going to put those. But before we do that, there is a really critical step that we need to take. Now at the end of the day, we need to make this model so that it has a CG, a centre of gravity, front to back, as specified on the plans here. And that's where the CG needs to be when we're finished, if we're going to fly this model. Now we've got two choices at this stage. We can fit all of the servos as shown on the plan. It shows the servos here, a throttle servo here, and we can just put them in and hope that it's right, and then at the end of that we can test to see where the CG is, and the chances are we may have to add a little bit of lead to the tail or to the nose to make it balance to get that CG. What is far better is to mock this up now. So what I mean by that is to fit the engine, put the ailerons back on, the aileron servos, we'll get the wheels on, essentially everything that we can't move. So the engine we can't move, it's got to sit on the front. The tailplane we can't move, it's going to sit on the back. So we mock this up with everything that we can't move, and then we see where the natural CG is falling. And if we find that compared to this CG it's a little bit nose heavy, then we need to have the servos back here. If we find compared to this that it's tail heavy, then the last thing we want to do is put the servos way back here and add more weight to the tail. Much better to have some longer push rods, nice carbon fibre, nice and light, and to have the servos up front, or further front anyway. So what we're going to do is, as I said, we're going to mock this up with everything we can, and we're going to see where it is, and that will inform us on where we need to put those servos. I mean, we've got things like the battery, which can essentially move from about here to here. So there's a lot of scope to alter the weight of this, but far better we do that informed by where the CG is now. I've got one more thing I need to do before we can mock this up. In the last video we got the locking mechanism in the back here, built for the back of the wings, and built the turtle deck. So that locks in the back now, but what we need to do is we need to get the locking mechanism in for the front here to hold that in place. And I'll move the camera around and I'll show you exactly what I'm going to do. It's going to be a fairly easy process, and we've done the preparation in advance for that. Now to hold this front down, we're going to have a couple of legs, basically 3mm plywood, that is going to slot down the side here of the engine mounts and on to the inside of these cheeks here, one either side. And if I just lift this off, we can see that I put the holes there ready for that plywood to slot through. And if we look at the inside, you can see that these will come down on the inside. Where is it? Oh, there we go. On the inside of those engine bearers, and they will epoxy there, and that will hold them really nice and secure. So essentially we'll have a little bit of this 3mm ply sticking down like that, and on the fuselage we can see that we put some, when we built this, we put on some thin, I think this is 1mm ply on the inside of there to strengthen that so that it doesn't just pull the bolts through the soft balsa when we do it. So what I'm going to do first is I'm going to get in the pieces of plywood sticking down, and then we will drill the hole through here, and then I can drill through that and into those lugs that are going to be sticking down. Now once I've got to, well, before I drill this hole here, I'm just going to put a bit of CA around where I'm going to drill, just on either side of this soft balsa, because it will just harden it up and it will stop it ripping up the balsa. I'm then going to cut a little bit of brass tubing, which has got an internal diameter of 3mm, and I'm going to use 3mm locking bolts, and that just slides in, and I'm going to use a bit of this just to bush that there to strengthen the balsa where the bolt goes through, just so it doesn't wear and become sloppy. So I'm going to get that done, and oh, and one other thing, on the inside of these cheeks, we'll come back and have a look at this, or the inside of these legs, I'm going to put a little bit of balsa, and I'm going to put in a captive nut like that, and then that will go down the inside and these will go through and screw into the captive nut. So I'll get on and do that now, and then we'll come back and have a look. Right, a quick update. I've drilled the hole and put the brass bush in there. Hopefully you can see that, just flush with both sides. I've drilled the hole this side, but I haven't put the bush in yet. But you can see that's quite a nice, I haven't touched that hole since I've drilled it, but you can see it's a nice clean hole. Hopefully, I don't know how close this will focus, and putting the CA on really does make a difference to how that hole ends up. Now I've glued the tongs on either side now, and if I turn that over you can just see them sticking down. So I will get the other bush in now, and then we can get this drilled through. What I'm going to do, if I just put this on, there we go, that goes down. Once I've got the bush in, I'll run a drill through. Holding this, I'll probably put an elastic band on just to make sure it's nice and tight. Right, well, I've now got that attachment point finished, and I've got the bolts in. As you can see, they're not screwed in because I wanted to be able to take them out quickly to show you, but that doesn't even move even though the bolts aren't tightened. It's really secure. And if I just take out the bolts and then lift that up, nice snug fit, and if I turn it over, we can see I've got the balsa on the inside. I think it's 1/4 inch, looks like 1/4 inch, 3/16, and then I've just got the captive bolts there, and so the bolts, machine screws, just go into there and pull the side. What I might do, or pull it to the side, what I might do is just put a little bit of a chamfer on there so it just goes in a little bit smoother. But to be honest, it's a nice tight fit and probably doesn't want touching. As I said, there we go, look, really good, really nice and secure. I'm really pleased with how secure and precise this fitting of the wing is onto the fuselage. So all that's left now is for me to mock this up and see where that CG is. Right, well, I've now got this totally mocked up, and I've more or less got everything on there that needs to be on there that can't be moved. There are a few things, like I haven't got the control horns or the 2mm bolts that are going to go on that. There's a couple of bolts here for the shock absorbers. I have got the shock absorbers on, but just not the fixing bolts. So there's a few bits and pieces, and there's a bit of thin balsa that's going to go on there, a little bit of shear webbing will go in the centre. So it's not exact, but it's going to give us a good idea. And here on the bench I've got throttle servo, elevator servo, the rudder servo, the battery and the receiver. And now all of those we can move a little bit. So it's going to be really interesting to pick this up and see where the CG is, whether this is tail heavy or nose heavy. And whatever model I build, I always find this really interesting. So I've marked on the CG points where it should be for this to fly good. And if we lift that up, whoa, we can see that is really nose heavy. Now, this is a carbon fibre that I'm going to use for a push rod. So you can see from that this is really nose heavy. So what we need to think about doing is placing these servos as far back as we practically can. And I'm going to put these here, which is, which is right at the back of this turtle deck section here. When we take that off, they'll be clearly accessible. I'm also going to put the radio behind the CG in the kind of central but back of the CG. We've got the servo for the throttle. I would quite like to have that around this area, so I will put that there, and now we'll see how this is and whether that's made a difference. We have to remember we've got quite a big engine on this. Now that is still nose heavy, but it's not quite as bad. Now we've got the battery, and the battery's great because we can, we've got the fuel tank on the floor here. It's obviously not going on the floor there, but it's going to go in that location. So now we've got the battery, which is really good because we can essentially slide the battery right up to the nose or right back. So I think this needs to go right at the back, probably just in front of those servos, and we'll see how that goes. And that now is starting to balance pretty well with the battery back there. So what I think this is telling us, essentially, because essentially this whole exercise is telling us where to put those servos, because the battery, we've obviously got a big area we can, just put this down properly, we've got a big area we can move that over, and we just want to know where we put the servos, because if it was really tail heavy we'd be putting the servos way up front. So, but that tells us that the battery and the servos need to go back as far as possible. Basically we need to get as much weight back as possible, and if we put too much back, then we've always got the battery we could move way up front if necessary, and that would really tip the balance. Now, one of the things I often like to do at this stage is get the whole thing on a balance and see what weight it is and try and think about or estimate what the finished weight's going to be, just out of interest really, not that I can alter it that much at this stage. And this is coming in at about 1200 grams, which is a little bit heavier than I expected, but we have got this huge chunk on the front, and actually it's got a huge wing area, so it's not going to be a problem, and it's within the published rates by Clancy Aviation, so we're kind of on track. But it's set me thinking about all of that weight on this, potentially at some point on landings, on this tail spring, on the tail wheel here, and the pressure that's going to put, because all of that is taken on this fin, and the pressure that's going to put on the fin and the two hinges. And I'm just slightly concerned that if we come down a little bit hard on the tail, it may well do some damage to the hinges or even to the fin itself. So I keep going back and thinking about this, and I'm tempted to put on a nose wheel a tail wheel like this, which actually puts the main weight on the fuselage and just hooks into the fin. So I'm thinking about modifying that a little bit, still using those original hinges we've got, but like I say, just taking the pressure off the fin and putting it onto the rear of the fuselage. But I'll think a little bit more about that and if I do, I will do a video, or at least video it and show you how I'm modifying that. But I think I'm going to draw this video to a close now, and that's given us some really useful information that's going to allow us in the next video to get these servos and controls fitted out and get this plane almost finished and ready for covering, hopefully. So thank you very much for watching. I hope you've enjoyed it and found it useful, and please come back and see how we get on in the build of this fantastic 40-inch Clancy Aviation Speedy Bee.